Okay, so really fast, because I admit we've done something very similar. I just want to look at graphing h of x is x squared minus 4x plus 4 over x squared minus 4. And I acknowledge that we just did this, right? So factoring this should be really easy because we just did it. Should be x minus 2 squared over x plus 2 times x minus 2. Right? Which is
X minus 2 plus 2 when x is not 2.
Okay, so you'd love to say, okay, so this is the same thing as x minus 2 over x plus 2.
And x is going to be negative 2.
Yeah, except this one actually does have that asterisk.
So that means that the asymptote is at negative 2.
Right? So if I go to draw this,
X is negative 2.
x is negative 2 definitely has an asymptote.
Except positive 2 is a horizontal asymptote.
Wait, are you saying except x is 2?
So x is 2 was the where x minus 2 over x minus 2 wasn't 1, right? Is that thing an asymptote?
That's a whole.
Yeah, it's not an asymptote, it's a hole. You guys see that? So I'm just not allowed to plug in x is 2. So if I go over here, that value is not going to be allowed. I don't know that it goes here, but it goes somewhere, and that somewhere needs to be a hole punched in my picture. So what should this thing be at x is 2?
Should be 0.
Should be 0. Oh, so it does literally go right here. You guys see that? So that's going to be a hole in the graph of my function. And then otherwise, you could fiddle with some limits on this thing. Right? You'll figure out it goes to 1 in both forward and backwards. Right? So you've got this horizontal asymptote. And then you could you could dart around it a little bit and figure out that you get something like this.
So it's not the inverse. It's the reciprocal.
Yeah, it's not the inverse of the function we just looked at, it's the reciprocal. Right? So if you remember what the function we looked at before looked like, the function before looked like this. Let's see, and that one had an asymptote at 2. Right, which is a little, so this looks a little funky, right? It kind of looks like I reflected it across the horizontal asymptote. It's because I literally just did h of x, right? Which was the function I had before flipped over, right? So it should be 1 over g of x. You see that? So when you do 1 divided by something close to 1, you get
1.
something close to 1, right?
Yeah.
So that's why the tails kind of remain the same. Except when the blue thing's a little bigger than 1, 1 over the blue thing's a little smaller. And when the blue thing's a little smaller than 1, 1 over something a little smaller than 1 is just a little bit bigger. And so those guys seem like they flip. And why did the asymptote trade spots with this hole?
Because it's being reflected over the y-axis.
So what was 0 over 2 is now 2 0.
Yeah, right? This guy went through 0 there. Right, that blue dotted one went through 0 there. 1 over 0 is undefined, hence the new asymptote.
Oh, yeah.
And then the other one had an asymptote here that was guarded by a hole. When I flipped it over, I just see the hole because 1 over infinity should just be 0, right?
Yeah.
You guys kind of see that?
Yeah.
So if I hadn't had that hole in the first one, this dot would be just filled in here.
Makes sense.
You guys cool with that?